Section 4.3, triangle congruence. We're going to prove triangles are congruent using side, side, side. So we are going to work on starting to prove things. So we're going to determine whether triangles are congruent using some postulates and theorems in the next several lessons. So in the last lesson, 4.2, we did learn that the only way to prove triangles are congruent is to show that every angle and every side is congruent to its corresponding angles and sides of the second triangle. That is, you'd have to show 6 different items to prove congruent. You'd have to show 3 sides are congruent and 3 angles. Is there an easier way? Well, it turns out there is. And we could explore having everyone draw a triangle with sides that are 4 centimeters, 5 centimeters, and 6 centimeters. Seems easy enough to do, but actually when you try to draw this, it actually is a little tough. But if we do this, what would happen is when we measure all of the angles, all of our angles would be the same. So, if all of our sides are the same and all of our corresponding angles are the same, then that's actually a short-cut way of proving 2 triangles congruent. And so that is our first triangle congruence theorem. This one happens to be a postulate, but the side, side, side congruence postulate says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So we can prove 2 triangles are congruent using side, side, side. So let's take a look at these examples at the bottom. Decide whether the congruent statement is true. Explain why or why not. So can you prove triangle ABC is congruent to CDB? Well, if I'm going to do that using side, 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 I have to show and prove that side AB is congruent to CD. Well, AB is marked with 1 tick mark and CD, oh, that is the wrong one I marked. AB is marked with 2 tick marks and CD is also marked with 2 tick marks. So those 2 sides are congruent. We'd also have to show that side BD right here would be congruent to side BD. Well, if you look at this picture, side BD in both triangles is the exact same segment. So that side is congruent to itself. So yes, those 2 sides are corresponding and congruent. And then the last one we'd have to show is AD and CB. Well, AD is marked with 1 tick mark and BC or CB is also marked with 1 tick mark. So yes, we can prove by side, side, side because all 3 corresponding sides are congruent. So let's look at the next one. If we're going to prove these are congruent, we would have to show that RT is congruent to RT. Again, notice that is the same in each triangle. It's going to be congruent to itself. So then we check the other sides, RS and RQ. Are they marked congruent? RS right here is marked with 2 tick marks. RQ is also. So yes, that one checks out. And then we have ST and QT. And they are both marked with 1 tick mark. So yes, side, 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 the triangles are congruent by side, side, side. Okay, so let's keep moving on. So far, so good. So again, you have to look at the congruent statement. So I have to show that AB is congruent to DE. Well, AB is 10 units and DE is also 10 units. So yes, marked the same value. Okay, so what about BC and EF? Well, BC is this segment right here. And EF is this segment. I'll mark this one in pink. So they're overlapping a little bit. So are those congruent? Well, if you look at this is 2 and this is 2. So it each has 2 up to that point, and then this piece in between is got to be the same length because it's the same part of the segment. So if we kind of call that piece X right here, then what we would have is we would have that BC is X plus 2 and EF is X plus 2. Whatever X is, when we add it to 2, it's going to be the same. So yes, those two segments are congruent. And then last but not least, if we check the last segments, AC and DF. So AC and DF, yes, they are both 8. So yes, again, the triangles are congruent by side, side, side. So we have to start looking to see, is that always going to be true? So far we had 3 examples where we had the triangles were congruent. So here's another one. Decide whether you can prove triangle ABC is congruent to DEF. Well, if ABC is congruent to DEF, then AB and DE have to be congruent. So AB is 7 and DE is also 7. So yes, those are congruent. What about BC and EF? So here's BC. And again, I'll mark that other one since it's overlapping. So now we have EF is this segment right here. So we have this overlapping piece again. And again, we could call it like X. But what happens here is BC is X plus 2. And EF is X plus 1. So BC, that segment, is not congruent to EF because whatever X is, one time you're adding 2 and the other you're adding 1, so they won't be congruent. So no, our triangles are not congruent. All right, so here is, I'm going to walk through kind of how we could prove with some given information. Now, this is a little more complicated because we're given information that's not marked on the picture. And what we are trying to prove overall is we are trying to prove that triangle ADC right here is congruent to triangle CFA. And what you have is overlapping triangles. And so a lot of times what's going to be easier to do is actually draw those triangles separately. So I'm going to try my best to draw triangle ADC. That was the yellow one. And I'm going to draw the other triangle that's in there, AFC. And those are my overlapping triangles. So I could highlight them the same color that I drew them in the picture, or that I redrew them. But that's what we're looking at. So can we prove those triangles are congruent? Well, let's try. So let's first look at they tell us that AD is congruent to CF. So AD is congruent to CF. That's one thing we have to check. Well, good, let's mark that. So AD is congruent to CF. Then it also gives us that DC is congruent to FA. So DC is congruent to FA. That's another one we have to check. So let's mark that. So DC is congruent to FA. All right, so we have 2 sides that are congruent. Is the third side congruent? Because we still need to check to see if AC is going to be congruent to CA. So AC and A and CA are this bottom segment right here. And it's the exact same in each triangle, so they have to be congruent because it's the same segment. So yes, these triangles are congruent by side, side, side. So I just walked through and explained it to you. What we're going to start to work on is we're going to actually start to prove that they are true by using the given statements, like the fact that AD is congruent to CF, and we see that DC is congruent to CA, and then we also showed that AC was congruent to CA, and so we can say this statement right here. So they are congruent by side, side, side. So first I verbally kind of proved this, then I sort of wrote it down to convince you that I do in fact have the three sides. So what changes from this to an actual more formal two-column proof is we have a column that says statements that we're making, and we have a column that says reasons for being able to say that. And so that first statement, the reason I was able to say that was because it was given. It was in this given piece right here. The second statement was also given. And you could actually often just put those on the same line. The third statement I made, I wasn't given that information, but it's the same segment, and that is our reflexive property that allowed us to say, hey, the same segment is congruent to itself. And so then the piece that I add is, now that I have shown you that all three sides are corresponding congruent, then I can say that triangle ADC is congruent to triangle CFA. And the reason I can say that is because of side, side, side triangle congruence postulate. And that is a more formal proof. And again, we'll keep working on these as in this next 3 lessons. So, I think we just did that one above. So that somehow got in there twice. Sorry about that. And so now let's see if we can figure out, okay, this is just showing you the side, side, side congruence postulate. So if triangle ABC right here is congruent to DEF, we're given that information, then what are the measures of angle A and angle B? Well, remember, we can tell that these are congruent because it gave us this statement. So that means this side is reflexive and the same, because we know that DB right here that statement is from the one above. Sorry. DB would have to be congruent to DB. And so now, from this congruence statement, we know that angle A is congruent to angle C. So angle A is congruent to angle C, so we can mark it. And that means then that angle A, the measure of angle A, is equal to 39 degrees. We also are supposed to find angle B. So angle B, right here, angle B is congruent to angle B, but here's the thing. When we draw these triangles separate, this is angle B in this triangle, and this is angle B in this triangle, so this is 72 degrees. We want to find this angle B, so now we can use triangle sum theorem since we were able to get this piece over here. So that means that the measure of lowercase angle b is equal to 180 minus 72 minus 39, which gives us 69 degrees. All right, one more example here. So now we have to decide whether two triangles are congruent, and we are only given the ordered pairs. Well, of course, we can graph these two triangles. So if I graph triangle A, I would graph 1, 2, here's A. B is 4, -3. And C is 2, 5. So here's my triangle. I'm supposed to decide whether that triangle is congruent to DEF. So let's plot DEF. D is 4, 7. So here's D. E is 7, 2. And F is 5, 10. So here's our second triangle. So if I'm going to prove these triangles are congruent, just like before, from this congruence statement, I am going to have to show that AB is congruent to DE. So what I need to do is I need to find the length of AB, and I need to find the length of DE, and I'm going to do that using the distance formula. So here is A, and here is B. So first I'll take the difference in the x's, so 1 minus 4 squared, plus the difference in the y's, 2 minus -3 squared. That's going to be -3 squared, which is 9. And this is going to be 6 squared, which is 36. So 36 and 9 is 45. So this is the square root of 45. Now I could get a decimal for that, but I really don't need to, because all I need to do is see if DE is the same length, which would make it the square root of 35. So now I'm going to do DE. Take the difference in the x's. 4 minus 7 squared, plus the difference in the y's, 7 minus 2 squared. So this is going to give me -3 squared, which again is 9, and this is going to give me 7 minus 2, which is 5, and this is 2 minus, oh, I did my subtraction wrong of my x's here, so let's change this. So I need to do 4 minus 7, no, that was right, 4 minus 7, and 7 minus 2, difference in the DE. So this gives me 9, yep, that was right, and then this gives me 5 squared, which is 25. So these value AB, just double checking my work. Oh, this gave me did some math wrong here, because this should have given me 25 and 9. That should have given me 34. Sorry about that. So I was like, thought the first two segments were at least equal. So this gives me the square root of 34, and this also gives me the square root of 34. So right now I know that AB, segment AB, is congruent to segment DE. So I can mark these two congruent. So now let's check another side. So we would need to show then that BC right here is congruent to EF. So now we can do the math for BC and EF. And then we'll also have to show that, we already used green. Maybe this will show up. We also would have to show that AC is congruent to DF. So AC is congruent to DF. So we're going to do the distance formula for those as well. So I would like you to plug those values in and see if you can decide whether the other two segments are congruent. So BC, what you should have gotten for BC is find the difference of the x's, so 4 minus 2 squared, plus the difference in the y's, negative 3 minus 5 squared. So that's going to give me 2 squared, which is 4, and this is going to give me negative 8 squared, which is 64. So this is the square root of 68. And you should have also gotten the square root of 68 for EF. So now we can say that segment BC is congruent to segment EF. And then finally, if you did your math correctly on the second one, the last one, AC, 1 minus 2 squared is what you would have. And then you would have 2 minus 5 squared. So that gives you 1 minus 2 is negative 1 squared. So that gives you 1. And 2 minus 5 gives you negative 3 squared, which is 9. So you get the square root of 10 for each of these. And so AC is also congruent to DF. So now we can prove that yes, the triangles are congruent. So triangles are congruent by side, side, side. So explaining my reasoning were all of those math steps that I did, and I also verbally explained, but this is kind of the piece that proves it and verifies it. And then this is the math that shows you that they are actually congruent. So that is the end